Welcome back, everyone. I am Rado. This is HackConf 2021 Online, the adventurer track. I hope you're having a great Friday so far because we have more interesting talks coming your way. Our next speaker is Georgi Stanev, who is a technical leader and a full-stack developer with strong expertise in mobile development. He worked in many commercial projects in various business domains such as trading platforms, network monitoring systems, reporting systems, and more. He's going to talk about building scalable, maintainable, and robust apps with Flutter. So, you know the drill already. Spam the chat. Georgi, take it away.
Hey everyone, I hope that you're doing great, and hopefully during this conference you will learn something new and exciting. In my talk, I'll start first with some architectural principles for building not only Flutter applications, but applications in general. Then I will list some of the most popular state management solutions in Flutter, and finally we're going to build a real app for just 15 minutes. So, as you might know, a couple of years ago, it was nearly impossible to build an app for iOS, Android, desktop, and even the web with a single code base. But nowadays, Flutter opens the door for handling this challenge, which is quite powerful. But as you know, the great power comes with great responsibility. My name is Georgi Stanev. As you know, currently I'm working as head of mobile development and Prime Holding / Programmista. But for the last 12 years, I've been using various technologies and tools. I've been working as a backend engineer with PHP and Java, and then I switched to application development for iOS and Android, respectively with Swift and Kotlin / Java. And for the last 3 years, I've been using exclusively Flutter for building iOS, Android, and even web applications. To be honest, in my career, I've done lots of mistakes. I've been using overcomplicated architecture for simple applications with the potential to grow, but in reality, this never happened. In other words, the effort and the energy that we've put on building awesome infrastructure didn't pay off. From the other hand, I've been using way too simple architecture for applications that, at the end, wasn't able to cope neither with the growing business requirements or the need for scaling the team. And today, I'm very excited to share with you my experience in building maintainable, scalable, and robust applications in Flutter in the most efficient manner. But let's first quickly go through the main pillars. What actually means building a scalable, maintainable, and robust application, not only in Flutter, but in any technology. Speaking of scalability, you might be working on an app that requires a highly interactive UI, heavy business logic in combination with consuming various data sources. Probably during the product development, you need to solve tons of complex problems. For instance, you could have multiple features, and in order to keep the features decoupled from each other, you need to establish inter-feature communication channels. So for handling these and even more challenges, you might need big development team, like 20, 30, even more engineers working on a single project for years. But let's assume that we have built our MVP and it's already on the market. So from that point, we need to start maintaining that application, right? We need to add new features, we need to enhance the features that we have already built, we need to fix bugs, etc. And in order to do this efficiently, we need clean separation of concerns. Let's assume that currently you're using Firebase for data storage, but you might need to migrate to your own REST API or GraphQL. And at the end of the day, you don't need to rewrite the entire application, right? You can just adjust your data layer so the business rules and the UI layer can work just as before. Speaking of productivity, we need to be very picky about using the right tools that work for the project and for the team, right? There is no universal hammer. Speaking of cost efficiency, Flutter is cost efficient by default because we can build our application just once and then we can distribute that application to multiple platforms, which is good and bad. It's good because you can distribute a feature simultaneously to multiple platforms, but along with that, we can distribute a bug at the same time to multiple platforms. And here's where Flutter really shines. There are a lot of frameworks that can help you achieving stable application. There are widget and golden tests, so you can ensure that your UI is looking as expected. All the UI components are aligned properly, the paddings are properly. In general, you have pixel perfect application. Then we have unit tests, so we can ensure that the business rules of your application is working as expected. Imagine that you need to work on, let's say, a fintech application or ERP, and you don't want to cause any regression on the business layer, right? Those frameworks, they are great, but actually they're testing a specific layer of your application. What if you want to test the entire application along with the API that this application consumes? So for this, we can use integration tests. Basically, we can write end-to-end tests to test a particular flow of your application. Let's assume that you have multi-step onboarding flow, and this will be the first experience for your users. So you don't want to cause any regression on this, right? It's a very critical part of your application. And now the question is to use an architecture or not to use. Let's assume that you need to start building your next or your first Flutter application, and you might not have the time to invest in the infrastructure. Or you might be like, no, I don't need architecture. Let's start building the feature right away. So basically, you start, and in a couple of months, you have application where you fetch some data from API, you store some of the data locally, you have some data model, some UI, you have some business logic. Probably you might use platform-specific APIs to access geolocation, camera, etc. And your code base might be not as efficiently organized as possible. But at the end of the day, you manage to deliver, which is very important. In other words, you have achieved your short-term goals. But what happens when you need to expand that application? What happens when you need to build new features, when you need to enhance the features, etc.? So at that moment, you realize that your application is not scalable, your application is not maintainable, probably you won't be able to write neither UI tests or business logic tests, but still you can add integration tests. Actually, using architecture is not bad, right? And it shouldn't be overcomplicated. Remember, we want to achieve our long-term goals, but at the same time to keep our team as productive as possible. So let's first start with the basics. We have just 3 layers, right? Nothing else. We have your layer, we have business layer, and we have the data layer. So within the your layer, we are not aware where the data is coming from. We are not aware of the business rules of our application. We have just UI components, right? Nothing else. Having this separation of concerns allows you to write widget and golden tests. How? You can just mock the layer below, which in this case is the business layer. And with that, you can test various scenarios, such as loading state, error state, success state, empty state, etc. Then the business layer is completely decoupled from the UI layer, which means that you can represent the state of your application however you like. Then we have data layer, where we can use various data sources, such as local storage, like shared preferences, secure storage, remote data sources. We can use, let's say, WebSockets, REST API, etc. And now the question is how those layers communicate to each other. So let's first start with the communication between the UI layer and the business layer. So from the UI layer, what we do is that we just push some events, such as button taps, typing on the keyboard, etc. And then we can listen for state changes. So we can react on those state changes, and we can rebuild the UI components accordingly. The business layer actually exposes only interfaces, only contracts, right? Doesn't expose any implementation details. So within the data layer, what we can do, we can expose repositories. So in that way, the business layer is not aware where the data is coming from. So this allows us to completely unit test our business layer, which is great. So let's now dive deep a little bit more into each individual layer. So within the UI layer, as I mentioned before, we have pure widgets, right? Nothing else. They don't contain any state, they don't have any business logic, etc. So first, for sure, we need to have navigator so we can navigate through the pages of our application. Then we have localization provider and localization resources so we can translate our application. And then we have so-called widget catalog, or in other words, reusable widgets, such as buttons, list views, cards, speakers, etc. All the components that are built specifically for your application. Of course, they could be based of the material components, but for sure they need to be styled and adjusted to fit your needs. And then we have pages, which are stateless widgets. Again, we don't contain any state within the URL layer. And now the question is how this layer communicates to the business layer. First, we have dependency injection, and then we have a kind of block gateway, so we can push some events, and then we can listen for state changes. Within the business layer, we have application sublayer and domain layer. The application layer is the bridge connecting the URL layer to the business layer using reactive streams. Basically, this sublayer of the business layer will be managed by your state management solution. Then we have the domain, which are services, contains and apply business rules on the entities retrieved from the data layer. Basically, this will allow you to implement DDD, domain-driven development. As I mentioned previously in the presentation, we might need to decouple the features as much as possible. So let's see how we can achieve this. Let's assume that we have user management, and basically we have two features there. We have list of users, and then we have possibility to edit a user, and basically those needs to be decoupled. So how we can achieve this? Of course, there are multiple ways, but one of them is to use the coordinator block. So basically we have one coordinator block that we inject to user list block and to user edit block. And as soon as we edit some user, what we do is we just send an event with the updated block to the coordinator block, and then the user list can listen for this event and can update its own state accordingly. This is very simple but very powerful technique. Imagine that you need to build another feature that needs to listen for this event. Let's say you need to implement Google Analytics, right? And you need to send that event to Google Analytics. Okay, so what you do, you just create another block and you inject the coordinator block to your new block so you can start listening for this event and you can do whatever you want. Okay, the data layer. Basically, we have two things there. We have repositories and we have data sources. So the repositories, they isolate the data access from the business layer. So again, from the business layer, we shouldn't be aware where this data is coming from. Okay. Then we have data sources such as SQLite, API Store, Bridge Adapter, etc. And the idea behind is that those data sources, they provide DTOs, so-called data transfer objects. But sometimes they have some specific from the data source. Let's say that we use Firebase or some platform-specific API, etc. And what we want to achieve, we don't want to expose those DTOs neither to the business layer or to the URL layer. So how we can achieve this? We can use entity to DTO mapper. And now the question is, how can you implement this? Basically, we have two options. The first option is to implement the DTOs and the mappers by yourself, but let's assume that you need to build hundreds of models. This is kind of tedious task, isn't it? And the other option is to use so-called metaprogramming, or in other words, code generation and in Flutter and in Dart. There are packages such as JSON annotation and JSON serializable that can generate all the DTOs and mappers for you. Okay, now we have a scalable architecture, we have a maintainable application, and of course we have a robust application. So now the question is, which state management solution should I use? And to be honest, there are plenty. Here I have listed only the subset of the most popular state management solutions we have in Flutter. The first package is the block package. It's a very popular package. It's a package with high quality, and I encourage you to give it a try. The second package is getEggs, which is not just state management solution, but also includes navigation management, dependency management, and much more. It's very powerful and it's very popular. Then we have Redux implementation in Flutter, which means that if you have already experience in building React applications, you can use the same knowledge for building Flutter applications, which is great. To be honest, all of these state management solutions, they're great, but unfortunately, I wouldn't have time to go through each of them. So that's why I'm going to focus on the Rxbox ecosystem, which is a set of Flutter packages that help implement the business logic component design pattern using the power of reactive streams. Basically, you're going to use reactive programming for state management. Be aware that the goal of all state management solutions is to make it easy to separate the URL from the business layer. Remember, from the URL, we just push some events, and then we can listen for state changes. And let's now see what we have within the Rxbox ecosystem. We have plenty of packages, and we have an Android Studio plugin that can boost the dev efficiency. Okay, the first package, of course, is Rxbox. This package helps to implement the business logic component design pattern using the reactive streams. Basically, this package will help you building the application business layer of your app. Then the second package is Flutter Rxbox, which exposes your reactive blocks to the URL. Basically, this package will be the gateway between the URL and the business layer. Okay? Those two packages makes your application scalable. Then we have Rxbox Test that facilitates implementing the unit tests for your block. This package makes your application robust. And then you remember that we have metaprogramming and code generation, and there is a package that uses those techniques, which is called Rxbox Generator, and boosts the development efficiency by making your blocks zero boilerplate. So, in other words, this package will generate all the infrastructural code so you can focus on the feature delivery instead of supporting the infrastructure, which is great. Then the plugin for the Android Studio that effectively create reactive blocks in a second. And finally, we have Rxbox CLI that helps you creating fully functional and feature-rich projects in just a moment. So we have the architecture, we have the state management solution, and it's the time to build our application, right? And this is a booking application. Basically, we have hotels with some information about the hotels. We have plenty of hotels, and that's why we need to build an infinity scroll, or in other words, pagination. We need to provide possibility to refresh the list of the hotels, and that's why we have put refresh. And of course, we need to provide possibility for searching the hotels so our users can find the hotels that they're looking for. And of course, we need to have error handling. Okay, so now the question is, we have the application, we have the state management solution, we have we have everything that we need to start, right? And now the question is how we can start as quickly as possible. The state management solution is not enough for building applications. We need to have routing solution, we need to have translations, we need to have push notifications in future, etc. And usually we need to spend hours, even days for the project setup. But we don't want this, right? We want to start building the feature right away. So how we can achieve this? We can go to pub.dev, just search for Rxbox CLI, follow the structure for installing this package. It's very easy. With just one command, you can install this executable on your machine. Check what's included. There is a cross-platform support, build flavors, internationalization support, no safety, Rxbox as a state management solution, design system, testing, static analytics, Google Analytics, push notifications, and much more. Just open your terminal, type Rxbox CLI, create the name of your awesome project, hit enter, and your application will be bootstrapped in a second. Open your favorite IDE, like, let's say, Android Studio, and then check what's included. There is a base with application, common blocks, components, use cases, data sources, such as remote and local data sources, dependency injection, extensions, models, repositories, routers, themes, utils, and much more. The project will be organized by features, which means that you have a folder for each feature with blocks, DI, and views. For sure, you can go to the documentation and to read all the details like project structure, architecture, feature structure, etc. Be aware that this will be the base for your technical documentation. This will be your default README file, which is great. So just run the application, and you can see that we have a counter app, which is a little bit more enhanced. Why? Because here we handle async states, such as loading state, error state, success state, etc. But let's now build our application, right? Let's go back to the Android Studio and make sure that you have installed the plugin for Android Studio. Okay, just right-click on the lib folder, type on new, type on Rxbox feature, and give it a name, configure it however you like, and you can see that that plugin creates a brand new folder that includes blocks, DI, and views, everything pre-configured, so you can start building the feature right away. So let's first start with the data layer. We have repository, and what we need two data sources, and that's why we inject two data sources. We have how to remove the data source, and then we have connectivity data source. What we need to build? List of hotels, right? So that's why we have a method which is called getHotels. Okay, we check for connectivity. If the device is not connected to internet, what we do, we just throw an exception. Otherwise, we get the hotels from the data source. Having the repository is extremely important because here is the place where you can combine, you can merge, you can even swap a data source without affecting the rest of the layers. So let's now implement the contracts, the interfaces that we're gonna expose from the business layer to the UR layer. So let's start with the events. As you can see, we have just pure methods like filter by providing a query, reload by providing a boolean silently true false, okay, and then we have the states. We need to show hotels. That's why currently we have just one state, but be aware in the production apps you might have much more. So what we have list of hotels, which is wrapped in a result. Why? Because we need to handle async operation, right? So we need to handle things like loading, success, error, etc. And then we need to wrap this in a stream because the UR layer needs to listen for that state change. So let's now implement our block. First, for sure, we need to inject the repository that we have just built, okay? And now it's getting a little bit more interesting. So remember that we have Rxbox generator, right? So as soon as we start the build runner, which is the official tool for metaprogramming, the Rxbox generator will look for all classes, for all blocks that are annotated with @rxblock. And based on the contracts above, which are states and events, we generate some infrastructure code for us. This code will reside in $hotel list block, which is the abstract class that we need to extend. So because we have hotel state, we have one mapper. So we can implement the mapping between the events that are coming to the business layer and then the state that we need to output to the UR layer. So, but this is not the end, right? So we have two methods, and somehow we need to get the events that are coming from the UR layer, and we need to work with them in a reactive manner. And that's why that tool generates two subjects. We have two methods, and that's why we have two subjects. We have underscore $ filter event, and then we have underscore $ reload event. What are the requirements of our application? We need to fetch hotels in two scenarios. The first one is when the users are searching. The second is when the users are refreshing the list by using the put refresh functionality. So let's see how directive programming can help us achieving this. We can use rx.merge, which is part of rxdart. And basically what we do, we just merge those two reactive subjects to just one stream. Then we apply back pressure. This is very important. Why? Because we don't want to overload the server with too many requests, right? We want to execute that request, that HTTP request, as soon as the user stops writing. And then we just fetch the hotels. And that's it. This is everything that we need to implement in our blog. But you might be asking, all right, where are the implementation details? Here we can see that we have some methods such as fetch hotels, map to payload, etc. But actually, I need to see the implementation details. So by using Rxblock plugin for the Android Studio, you can keep the implementation details apart from your blog. Why? Because in this way, you improve the readability of your blog. And this is very important. Why? Because imagine that you have a new team member and he or she needs to see what you have within your blogs. And you don't want to overload them with too much implementation details. So how we implement this? We use extension methods, which is very cool feature in Dart. What we do? We have, let's say, extension reload data fetcher on stream of payload. And in compile time, we add one method which is called fetch hotels. And this is very important because in that way, our code becomes more fluid. You see that we have some operators such as the bounce time, which is coming from RxDart, okay? But then you need some project-specific code. And in that way, you can improve the readability of your code. Okay, so nobody wants to write boring boilerplate code, right? Let's have a look at the boilerplate code which Rxbox generator will write instead of you. As you can see here, we have the reactive subjects, we have the implementation of the methods that actually pass the value coming from the URL to the reactive subjects. We close those subjects so we make sure that there are no memory leaks, etc. There is no black magic, which means that you still can debug that code, but on a daily basis, you don't need to look at it. Okay, let's set up the dependency injection. So we have the data layer, we have the business layer, and we need to wire those two layers together. So what we use for dependency injection, we can use multiple packages, but one of them is the provider package, which is package that provides DI and at the same state management. But in this case, we use just the DI part, just the dependency management. Okay, so what we do, we register hotels remote data source, then we register hotels repository, and then we need to inject the data source into the repository. And how we do it? We just call context.read. And because Dart is static type language, that package can determine the type of your dependency and can do automatic lookup in order to find and to provide that instance to you, which is amazing. Then we have hotels block, and we have the same concept. We have repository, we call context.read, and the provider package will be responsible for creating and providing that instance to you. But this is not the end. Somehow you need to wire the URL to the business layer, right? So, of course, there are multiple ways of achieving this, but one of them is to use auto-route package, which is a sophisticated package that enables you to write more declarative routing. Okay, we have hotels page, which of course is stateless widget, which implements an interface from the auto-route, which is called auto-route wrapper. We must implement then wrapped route, and what we do here, we just provide the DI that we have configured already. Okay, so Flutter, it's about building UIs, right? So let's build that beautiful UI. What we have? We have list page, which of course extends stateless widget. We don't want to keep any state within the URL, right? So what we use? We use Rxbox Builder, which is part of Flutter Rxbox. Of course, there are plenty of widgets. This is just one of them. So then we need to specify the contract, the interface of our block, which is hotel list block type, and then we need to specify the state of our block. Remember, we could have multiple states per block, and that's why we want to specify which exactly state we want to listen to. Okay, and now is the part of widget catalog. We have loading widget, which is part of our widget catalog. currently, we use circle progress indicator, but we can use whatever you want. You can use, let's say, shimmer, also called skeleton loading indicator, etc. And you can use this widget everywhere within your application. If you decide to switch to another animation, let's say, you can do it like this. Okay, then we need to handle the errors, right? And that's why we have built error, where we provide widget from our widget catalog, which is error retry widget. We have access to the block, which allows you to build some cool features such as tap to reload. And finally, we need to show the hotels, right? We have build success, and what we do, we just provide list view.builder. We need to provide the length, the size of the list, and then we need to provide hotel card, which will visualize each hotel. Okay, that's it. Let's recap what we have achieved. We have data layer, we have business layer, we have your layer, just 3 layers, right? Within the data layer, through the repository pattern, we isolate the data access. Then within the business layer, we declare the contracts, events, and states in a declarative manner. Then we implement the block in a declarative manner, and then we separate the implementation details through extension methods so we can improve the readability of our block. Then we register the DI within the URL layer so we can access the business layer, actually the contracts, the interfaces from the business layer to your layer. And then we use Rx Result Builder for accessing the register blocks. For sure, we just scratched the surface of that state management solution. If you want to learn more, just go to pub.dev, search for Rxbox, and there are plenty of resources that you can really deep dive. There are samples, articles, even video tutorials, etc. So that's it. Now is the time for Q&A session, and I will be more than happy to answer your questions.
Yep. All right.
Okay.
Hey, sorry, that was really interesting. I was looking at Flutter documentation backstage.
Nice.
Because you got my interest. Yeah, we have a couple of questions, so I'm going to ask them one by one. The first one: what would be your recommended method for testing Flutter applications?
So as I mentioned, there are 3 ways of testing, right? It depends on your needs. You can test either at the URL layer by using the widget test and the golden test. The golden test is very useful when you want to have pixel perfect application. Basically, we have a widget, and you, by running just one Flutter command, you have a screenshot of that particular widget, which is in isolated manner, right? It's not coupled with the data layer, etc. So then imagine that you continue working with the project, but you want to refactor that widget, right? Without changing the interface. Yeah. And this allows you to do easily refactoring. How it works, you just run the test, and then that test compares the previous state, the previous screenshot with the current one. Right. Yeah, of course, there are unit tests. There is no black magic. You can use, let's say, Mockito, etc., and integration tests that can test the entire application.
All right, all right. Second question is, what are Flutter capabilities with when working with native features?
Yeah.
I suppose this question is coming because most of the frameworks like Flutter or React Native or Ionic, they kind of struggle working with native features.
Absolutely, absolutely. Yeah. So how this is working? All right, so Flutter paints the pixels by itself, which means that it doesn't require anything from the platform, right? But when it comes to platform-specific APIs, such as camera, geolocation, etc., you need to have packages which are called actually plugins, right? So those plugins, you have basically, let's say, Kotlin for Android, you have Swift, and then on top of that, you have just one interface written in Dart, so you can consume the platform-specific APIs from each platform.
All right. Yep. Are the data models generated? What if you use Firebase, where the structure of the data can change?
The structure of the data. So we're not talking about the business properties, etc. Only the structure, right?
Yeah.
So this is a very interesting question. How we can achieve this? So we have business entities, and we can use, let's say, JSON serializable and JSON annotation. And by default, we have one-to-one mapping, right? But if the data changes, which means that you don't need to change the business entity, but only the data, only the DTO, what you can do, you have from JSON and you have to JSON, which means that you can write a mapper, a custom mapper for your case.
Right. So I'll expand on this question. Dart is a type language.
Yeah.
So can you have like the dynamic capabilities of I don't
Sure.
know what's the structure of this JSON, but
Yeah.
I want to use some part of it.
Absolutely, absolutely. Dart is a strict type language, which is great, but at the same time you have dynamic. So basically what we'll got from this DTO is something like string as a key and dynamic as a value.
All right. So the next question is, can you compare, if you have experience, React Native and Flutter?
Yeah, sure. So what's the main difference? I mentioned that the Flutter is in charge of painting pixels, right? But this is not the case with React Native. What you have in React Native, you have JS runtime that runs your business rules and your data, right? And then what you do, you send commands through a bridge in order to tell the platform-specific UI components to do something like building a list, tapping on a button, etc. So this is the main difference.
Right. And basically, those are all the questions that we currently have.
Awesome.
So thank you very much. To everyone, make sure to check out Flutter. Sounds really interesting. For sure, I'm going to check it out. And
Awesome.
we will be back at exactly 7 p.m. So have a nice break.